Well, thank you. This is our final episode of QA Science, and this was really, really spectacular talk. We have here honor students and we have local teachers, and so we have a lot of interest in intelligence.
Teaching.
Yeah, and teaching. Yeah, we can talk about that too. I have a question just out of the gates for you. Do you find yourself sort of annoyingly metacognitive about your own intelligence sometimes? Like, do you catch yourself thinking, oh, this is sort of irrational, I'm being rational based or case based, or you just kind of go
Only about other people.
Only about other people, but you don't find about yourself, you don't like this knowledge. How does it impact your sort of your own perception of yourself?
I think it does. And, honestly, I feel like I was just in a teaching workshop of some kind, and we were discussing how good it would be if people had more metacognition. Mostly we're thinking of students, not the teachers. But like I said, it's always easier to think about what other people should do better than, what your own illusions or misconceptions are.
Right.
But, often when we're learning something, education research shows that it can help if you have metacognition. If you think through, why am I either having a hard time learning this or having an easy time, or what were the strategies that I did use to learn this or that skill? Or what would be even better, but is hard, if you thought through, why am I resisting this new information? If you could somehow identify what that is. You were sort of asking about whether that could be negative, and and I think sometimes you can overanalyze things and you just have to get on with life. But in teaching, I actually think it probably helps to think through why we think the things we think.
Yeah, I would agree with that. Okay, well, let's turn to the audience. Where are the microphones here? Let's start over here with Noor. Go ahead.
So throughout your lecture, I know you specifically had this one slide where you were talking about teaching through economic principles, or whether it be enforcing rules through verbally. And you mentioned none of those were successful in teaching. So what do you think is the best way to really teach someone?
To have them build up that example library. And I think research bears this out. And I don't want to say that explicitly telling somebody what the rule or the consequence is, or explicitly communicating information never works. But it's very clear that specifically for skill learning, the best thing, and even for sort of internalizing and understanding, the best thing is to really, what in my language I would say build up those examples. But what that means is go through the motions many times, right? Go through it yourself. Have lots of examples where you, for example, use the scientific method, right? If you've experienced yourself lots of times asking a question and thinking about, okay, what are all the possible answers, even besides the one that I really like, then you just build up this, you can think of it as a pathway in your brain, or you can think of it as a machine learning rule that your brain acquires, right? You've gone through many examples, and so then when you're faced with a new situation where you have a question you want to solve, your brain automatically goes to, okay, this is what I always do next when I want to answer a question. I come up with the alternative hypotheses, or I come up with predictions. And so this is what I believe, and I also think research bears this out, that really this is why we emphasize hands-on teaching, right? In a lot of contexts, this is why a lot of universities go to more student-centered learning. It's not because student-centered learning, most teachers and most lecturers intuitively resist it, because intuitively they're thinking it's so much more efficient if I just tell you what all the rules are, right? Or I just tell you all the information is going to be much faster. Whereas if you have to do it hands-on, right, there's going to be lots of stuff not working and sidetracking and whatnot. But the fact of the matter is, nothing will make it, the whole rule learning thing works nowhere near as well as you going laboriously through many instances of actually doing something in a certain way, and then that is automatically what you're going to do in the next example.
That's great. Let's go over here and hand the mic over to Jim.
I think this dovetails well with that last one, but about metacognition, because we keep getting told that we need to teach people to be metacognitive, and the thing that does not work is saying, hey kids, you should be more metacognitive, because how do you get a rule example if, like, the voice that's in my head, you've now convinced me that I hear speaking is like a post hoc creation?
Yeah, exactly. So, it's funny. I actually, in my, we always have to give a practice talk of these. And my original version, it had another slide in which I said, well, look, this is really an open question. Why do we insist on believing that rules work? Why do we insist on believing that just telling your kids or your students or whatever the context is that this is what you should do, right? We all go to that, right? We all think somehow this must work. And yet we know that it doesn't work, right? You've tried it many times, it doesn't really work. Why do we have this in our brains? And I think this is really a question that psychologists should answer and haven't answered. But this isn't really answering your question. I mean, I think in the spirit of the example-based learning, what you have to do is give them lots of examples where their brain, just like with the route learning when you're driving to work, what you have to do is give them lots of examples where they went through the process, they got to the point of deciding how to study for an exam. And what I always do when I decide how to study for an exam is I think about how I learn best, or whatever the specific metacognition is that you want them to do. They have to go through those motions many, many times so that every time I get to Swan and Grant, right, I turn right at this point. And the same in their process of learning or studying or whatever the specific activity is. I think our current state of research basically shows that there is nothing that can beat that, right? No teaching method can beat having them go through it so many times that it becomes this, right? We think of it as becoming automatic, but it's still a brain process. But it's one that actually works. It's where you actually have that machine learning algorithm that says, okay, every time you get to here, this is your next step.
What's interesting about that, to follow up, is that when you ask people, can you draw an instance of when you learned something? And I've done this with a number of different people, faculty, students. Every single time I've done this, people will report that they learn by engaging in something, not by being told something. And yet you were saying earlier that we have this instinct to tell. Is there an evolutionary connection to that?
I am convinced that we evolved an instinct to tell people the rules. And that seems like a stupid evolutionary outcome. And I don't know why it's there, right? So I think nobody has the answer to that question. Why do we have this instinct?
It's kind of like the appendix or something. What's it? The organ, like the. Yeah, thank you.
Well, I don't know if it's vestigial, right? Because it's probably relatively new. I imagine chimpanzees don't have it.
Yeah.
But I can't give you an answer for why it's there. But I'm sure it evolved, and I think somebody should come up with hypotheses even why that funny notion about how our brain works evolved.
Interesting.
But we seem to have a hard time breaking through that.
Yeah. Jerry.
Yeah, so kind of going off that, but looking at it more in like a real life or like a parenting kind of situation, do you think this like experience-based learning could go that way? Like you mentioned the child with the goat, like if you tell them to hold the goat a specific way, they probably will still do it wrong. And then they'll learn a lot better when they do it wrong and the goat jumps out of their hands, something like that. Do you think this could say kind of like learning things the hard way might be more effective, like going through the situation?
Yeah, it's funny that you bring that up. I'm far from a perfect parent, and I actually don't know that I should lecture on how exactly to convince your toddler to hold the goat a certain way. However, based on the evidence that I was talking about, actually, the ideal thing would be if that child held the goat the right way 100 times, and then they would learn it. So it's not the hard way. I mean, different things can be hard, but it's, what I'm trying to say is actually it's not so much that you learn things that don't work. It's because then you have to still analyze, well, what did I do wrong, and what would be the right thing? You have to somehow derive that. Right? What I'm saying is you should go through lots of examples that do work. Sort of like in dog training, where really in dog training, modern dog training, people focus on reinforcing the good stuff rather than punishing the bad stuff. Because the fact of the matter is dog trainers and parents world over, right, for hundreds of years, maybe millions, have been punishing their subjects for doing stuff wrong. And it doesn't actually work that well, right? And so what works better is for them to go through the right thing many, many times. And so I don't know how to do that with the toddler, but if you can somehow coerce or bribe them or lead them into doing the correct motion, and they do the correct motion many times, that builds up that example library of, here's a goat, so now it triggers my next move, which is to hold it this way. And that triggers the next thing, which is that the goat is fluffy and warm and doesn't run away and doesn't kick me in the head. So, you want to reinforce that path to the right solution rather than, because if you just do the wrong solution, okay, you realize it doesn't work, but it doesn't tell you how you should do it. You have to somehow intellectually figure that out then. And that would be more on the side of the rational decision making.
Let's go over here with Jordan.
We've been talking about metacognition for a little bit now, but I'm having some confusion between them. There seems to be a contradiction between what we're talking about now with metacognition as a way of learning versus metacognition with, as you were talking about in your talk, where introspection is an illusion, where there's choice blindness. Would you mind giving me a clearer definition between the two and whether or not they're just completely separate topics that I'm confusing?
Yeah, no, this is actually a great point. There's no good definition for what metacognition is. And so I loosely define it as thinking about thinking or knowing what you know or something like that. But every one of those individual definitions you could argue with. So we'll leave it a little fuzzy. But what you're saying is, okay, if example-based learning is more effective, why do you ever need that metacognition? And you're right that that's a bit of a contradiction, and I don't have a great way to solve that puzzle. I guess what I'm trying to say is, and I didn't point that out very explicitly in the lecture, but it's not that I believe that there's never a rational decision-making, or that we never can internalize a rule or derive based on knowing what the consequences will be, what the best action would be. It's just that part of our brain or that part of our decision-making is way, way smaller than we usually think it is. So we intuitively think that all of our decisions are somehow made that way. But a lot of this evidence shows, like the jam thing, we think that we clearly had a preference for a jam, and then we come up with what those rules were. Why did we have that preference? And it wasn't really true. We just made that up afterwards. That's sort of a metacognition gone wrong. That is the whole illusion that I was talking about. And so my point there is, most of our decisions don't work that way, right? And behavioral economics is all about how we often make decisions that appear irrational, right? So economists and mathematicians like to call them irrational because they are somehow self-contradicting if you assume that you have fixed preferences for grapefruit over apple, or vice versa, or for a house being bigger is more important to you than a house being older or in the foothills or whatever, right? So whatever economic decisions you're talking about, classical economics assumes that they're based on certain preferences, certain values to the different payoffs, and that you calculate the right outcome. And it's not that we can never do that, but it's just that in many, many everyday situations, we're behaving irrationally if that were how we wanted to make decisions.
It's almost like we pretend to calculate for a while until we get tired of it, and then we just do something, right? Is that kind of what it's like? I mean,
yeah, the whole decision about when to stop thinking about something.
Yeah. So it seems like
there's a whole field of research.
Kat.
Yes.
So part of our discussion in class today was about how instinct and intelligence are like completely unrelated. But it sounds like when we build up this experience library, we kind of bypass the direct, deliberate thinking involved in like the choices, and it seems to become instinctual instead of like non-instinctual, like we do things out of habit. Is this part of our intelligence to create more instincts, kind of? That's my question.
Yeah, that's a great question. To tell you the truth, the funny thing is actual biologists, actual scientists never use the word intelligence, and they never use the word instinct either. And so people use it, and I use both of those words today, right? And we use them because that's how the general public sort of identifies what happens in the mind of animals and what happens in the mind of humans. But it has the problem that you point out, right? What is it if it's building up this machine learning like rule? Is that instinct or is that intelligence? And it turns out a lot of what we think of as intelligence probably works like that. So one way to say that is maybe that most of our decisions are instinctual rather than intelligent, but that's not really, that's not what we want to say. And there's this incredible value-laden undertone with instinct and intelligence. And I think the other problem with the word intelligence is, right, because of that, what I called irreducible intelligence, I called it that because I wanted a word for really this all or nothing concept. But we use intelligence like that all the time, right? So people will come out and say, do you think dolphins are intelligent? Well, what's that supposed to mean? Or we want to find intelligent life on other planets. What is that supposed to mean, right? Nobody knows anything. Nobody can give you a definition of what would be not quite intelligent life, or like where would be the boundary between those things. So, I'm sort of agreeing with what you said, which is that a lot of what we think of as intelligence is probably better thought of as instinctual in the way we normally understand that term, and perhaps vice versa. Yeah.
Oh, here. And you can hand the mic over.
So
to pass it.
where does emotions fit into decision making? You showed a little bit like with the stressed, I forget which insect it was, and how they behave different. And then I was thinking, we talked earlier in the before the lecture series about how some students are already being told that they can't do this, or it's too hard for them to do this, and so then they're starting to build up emotions and trying to build their intelligence. And
Yeah. So this is another funny thing with the term intelligence, and I think this comes from this whole rational and economic decision-making idea about intelligence, that in the general public, right, we have this idea that somehow intelligence and emotions are two separate things, right, that they somehow aren't quite connected, or they're in different brain halves or something like that. And of course, all of that is nonsense. So I like the way that Kati presented that last week. So she argued basically that the rational part is figuring out how to get something, and the emotional part is figuring out what it is that you want to get. Like, why do you want to do this, right? So the emotions are just a way of motivating or valuing different outcomes, right? We, like every other evolving being, are programmed to want to achieve certain outcomes, ultimately biological fitness. And so we like and don't like different outcomes based on what in our evolutionary history, whether they were positive or negative for our evolutionary fitness. So we don't like being, attacked, or we don't like being low in the social hierarchy. We don't like losing resources, and all of those that not liking is encoded as emotions. And then, of course, emotions have the secondary role of being a communication device, of basically communicating a nonverbal content to somebody else about what your value or your interpretation of a particular situation is. So I don't know if I quite answered your question, but what I'm trying to explain is that I don't think of emotions and intelligence as somehow being disconnected. I think of emotions being just a way to describe what it is that we want, and intelligence or rationality being a device that helps us reach the things that we do want, right, which are encoded by the emotions. So they are intimately connected. Do you want to ask more, or does that answer your question?
Let's go to Annie. We'll hand this mic back to Jacob and Sarah after Annie, and then you can hand that mic back there. Yeah. Go ahead.
Yes.
So kind of talking about the distributed cognition that you mentioned, do you think that relates in many ways to human society, or even on a more extreme scale, mob mentality? Would you equate those?
Yeah, that's a great question. So I think there's fundamental ways in which it is the same, and fundamental ways in which it's different. So when I'm talking about distributed intelligence or distributed cognition, what I'm thinking of is a system like an ant colony or like your brain, where the system has been shaped, the behavior of each agent inside that system has been shaped to achieve some intelligent or beneficial outcome for the system as a whole, right? So each individual neuron is somehow playing some small role in leading you to make an intelligent decision about whatever it is that you're making a decision about. And the same for the ant colony. But that is not the same for any human grouping, right? Every human in a human grouping has evolved to maximize the outcome for themselves and not for the group as a whole. And so the outcomes can be wholly different. So what the parallel is that very often something interesting and unpredictable or not easily predictable emerges when you put a group of things together, right? When you have a group of agents, a group of humans, then as a group sometimes they do something that was completely unanticipated from what you knew about the individuals. And the same is true for ants. But in the case of ants, we know that evolutionary history has shaped what the individuals do in order for the group behavior to be a sensible thing. And in humans, that is not the case, right? So there can be collective intelligence, right, in humans in the sense that humans as a group might solve a problem faster, or they might solve a problem slower if there's some trade-off that leads that to happen. So like, you know, you have the tragedy of the commons, which is this thought experiment or this illustration of the fact that if we all try to get the best out for us, we can actually lead to a worse outcome for everyone because everyone is trying to exploit the communal resource, for example. So that's a collective behavior that's not really easily predictable from what you know about individuals until you've thought about it or until you've seen it happen. But it's not actually a smart outcome for the collective.
Just a follow-up question on that. So how is it then that if humans are more sort of centered on their own individual, survival or whatever way you want to put it, how is it that we have such an emergent productivity? You know, like we can build a skyscraper, right? And that is a collective form, and it's a collective of many minds, and it's sort of analogous. We talked about a little bit in our class, like a bee colony builds a hive. I mean, isn't a skyscraper sort of just more of a sophisticated version of the same process? So are there, I guess my question is, are there similar evolutionary underpinnings that are operating both of those processes? It's just that we are more sophisticated and have also tendencies to be more self-focused.
Yeah, so that's a great question. It's a slightly different talk, but so in general, humans are incredibly cooperative compared to all the other primates, compared to any other mammal except naked mole rats, and most other animals, right? So in general, we are incredibly cooperative, and we do build skyscrapers in part as a result of that cooperativeness. But we're not perfect cooperators like the neurons in your brain are, right? So the neurons in your brain have zero selfish interest, right? They don't fight with each other over who gets to make the decision. But people do. So I'm not saying that people are always selfish. I think people are actually incredibly and surprisingly cooperative from an evolutionary standpoint. Just that they are not quite as cooperative as neurons or as ants. Right. I do want to add one more thing. So in current anthropological research, the problem is nobody knows why we're cooperative, just like nobody knows why we have big brains. So why did humans evolve to be so cooperative and then ultimately build skyscrapers? And some people argue that it is because of group selection, right? So people argue that it is because, to some degree, what I said was wrong. To some degree, we actually did evolve to do things in order for the group as a whole to survive. But that can only be true if it's actually true that in human evolutionary history, human groups had incredible competition with each other. So rather than just individuals competing with each other for resources, groups were competing with each other for resources, villages, tribes, whatever you want to call them. Human groups were aggressively and in a very fast manner, making each other extinct or growing so fast that they could then basically spawn new groups. If you believe that that's the case, then it could be that we are selected based on something that evolutionary biologists call group selection, that we actually evolved to be cooperative in part because it helps the success of the group and not just because it somehow indirectly helps ourselves. And that's another one of those questions that's not really solved. So some people will argue that that is in fact the case, and some people will argue that that's not possible.
Interesting. Let's go back here, and then Jacob, and then...
I was going to go back towards the example-based. So if somebody had a group-based question, okay. Now I'm very interested in, as a teacher and as a parent, the learning from example, building our example, our experience library, as you say. And I think maybe we give rules because we want people to learn from the examples we've learned, but I think learning from mistakes maybe is how I say that we need to build both sides of the line. I'm trying to draw the line between our introspection and our metacognition, and if we give our students ample chance to try and to experience and to build those right pathways, we need to give them a chance to make mistakes. And is it related to poverty of experiences, and how do we give children and adults enough chance? Can we help them build a library of experience? At what stage is it maybe too late to build that library of experience?
Well, I'm an optimist, so I like to not think. I like to think that it's never too late for anything, but I may well be wrong about that. But I think in general, right, we as adults can learn, even adult nervous systems. It's not true that as an adult you cannot grow new neurons, right? We used to believe that that's not true. So even late in life, you can learn stuff. Your brain can grow. And I think you can build up your example library at any time. I'm sure that people who start from the beginning have a head start, right? So as a parent and as a teacher and as somebody who votes, I think it would be good to start early, right? But I also think that you should not give up and somehow say that we've passed the point of no return. And I agree with what you said about building up the example library with varied experiences, right? So precisely one of the points I was making is if your decision making is based on these examples, is based on this machine learning like algorithm, it's only as good as the coverage of your example library, right? So that's saying in very abstract language, but basically if you only have experience with a very small set of situations, then you can only make good decisions in that small set of situations, right? Because that's the only thing that you have examples for. And if you have a situation that's outside of that realm, right, you have nothing to compare it to. You don't really know what to do with that. So I absolutely believe that this version of thinking about intelligence means that the more varied the experiences we can give, the better it is, because you get you can handle more different situations in the future because you have examples that are at least somewhat similar. So I think this variedness of experience is very important. And just to tag on to that, so I mean, going back also to your point about the metacognition, yes, to some degree, I think this whole idea about example-based decision-making and the intelligence being based on having examples to compare something to actually kind of argues that metacognition should play a smaller role. And if for all that we have learned and are taught in education or teacher workshops, right, that metacognition for students is good. If I had a choice between telling students about metacognition and having them go through several example situations or going through varied experiences like you were saying, I would always pick that, because I feel like that is the thing that we actually have good evidence will build those pathways in the brain, will build that example library where you can just, whatever the right term is, develop an intuition or have an automated, instinctual maybe algorithm that leads you to the right decision or the right next step. I think really that hands-on going through the experience thing is incredibly valuable for that.
Does teaching them about metacognition, I find, tell them what to do with those examples, so that maybe you're giving them examples, they're finding their misconceptions and understanding that they can discern between the examples.
Right, and so thank you for bringing that up. I feel like really this hits the nail on the head, right? I think what I was trying to say in the lecture is the vast majority of decisions we make in any context in life is based on that example-based heuristic or example-based decision-making. And it really does not involve ever trying to understand why or what exactly is different about these examples or anything like that. It's just sort of this automated thing. I was here before, this is where I go next. right? And you don't have to, this is the beauty of it, you don't have to understand anything about it. And this is why artificial intelligence, right, didn't start out doing that, because it seems so counterintuitive that that would work. But it turns out that is the thing that works. Everything else didn't work, right? So it doesn't actually require any of that metacognition or understanding where you went wrong or what your misconception was. But, and this goes back to what we were talking about before, as humans, it turns out we have some of that rationality. And every once in a while, right, our misconceptions in a way, right, is that red line that we built between the different examples that somehow went wrong because our examples were wrong, right? If you, to take an example from the last lecture series, if all the pictures of people in kitchens that you've ever seen have women in the picture, right, then your machine learning algorithm, both an actual machine learning algorithm and people's machine learning algorithm in their brain says if there's a person in the kitchen, it should be the woman, right? There's not some kind of value judgment associated with it. It's just that if that is what you've seen a million times, that is what you expect to see in the future, right? It's only, but the fact of the matter is, as humans, we are sometimes, right, very rarely, but sometimes we're able to step out of that and say, wait, this is why I think that. But we can break it, and we want to do it differently. And so I think that this is where the metacognition comes in, that every once in a while we have that light coming on, and we make that rational decision that is not really based on the examples, but based on some metacognition, thinking about why we're thinking what we're thinking, breaking through misconceptions. I think the scientific method, is an actual technique, is an invention that is not that old, depending on who you credit with it exactly. Maybe 200 years old, maybe 1,000 years old, but it's not that old in the grand scheme of things of humankind, right? That scientific method, that series of steps of first coming up with predictions and then sticking to your guns after you've got the observations and they agree with one prediction, not the other, right? That method is supposed to break through that example-based decision-making, right? It's supposed to break through all your preconceptions of what should be associated or your million examples of coming home and the dog wags and you think that they're happy, right? That is precisely what that technique is supposed to break through. So we can break through, and I think that is what the role of metacognition is in teaching. But it is incredibly hard. And so for toddlers, I don't know what age group you're thinking of when you're thinking of teaching, but the 3-year-old that I was talking about, right, it probably is futile to talk to him about metacognition, right, both explicitly and implicitly. It's probably better to just have him hold the goat the right way 100 times. Yeah.
Jacob, and then we'll go to Sarah.
So when I was learning how to use a shop lathe, or for a more like relatable situation, I'll drive a car. If I were to make a certain mistake when doing either of those things, then I would have died. So how, in a case where I'm trying to learn something, and I can take limited examples for one reason or another, is that where example-based learning breaks down, and you have to use other ways, and which other ways?
So I think example-based learning does not break down in driving, precisely because, driving is a great example. Because the fact of the matter is, yes, you have like a written test or whatever where you learn some rules about driving, like you should be on the right, and the sign means this, and so on. But there's a lot to driving that is not in that test, right? And the fact of the matter is that you learned probably, I don't know how old you are or how long you've had the license now, but over the years that you drive, you learn to drive better because you've been in much more situations. The actual rules about driving are not that complicated. It's not that many of them, right? So if it was just a matter of learning those explicit rules, it would be easy to learn to drive, but it isn't, right? You have to actually go through all these examples. Now, the point is a lot of people do die driving, and a lot of them are young, right? And it is because, well, this is what I'm saying, that is because they haven't got enough examples yet, and then maybe there are other factors that play a role. But what we hope, right, is that your teachers, your parents, or whoever set up some environments early on where every mistake wouldn't have immediately led to you dying, right? And that you were able to build that initial example library in a way that didn't, that didn't have that harsh consequences if it didn't always work. And we all make mistakes with driving, right? And it's not really because we don't know the rules. And I'll tell you one very culturally applied example. So Germans, I would argue, I'm German, so I can say this, are really sticklers about rules. And actually, this speaks to the evolution of cooperation thing. Sorry, this is like a little bit of tangent, but the evolution of cooperation thing, one argument that anthropologists make is that we could only evolve cooperation because we're so keen on punishment. So we're making the selfish interests of people work for cooperation because we're so willing to punish. And so, humans are unique with the level of cooperation, but they're also somewhat unique with their willingness to punish people, even at a cost to themselves. And there's many studies to bear that out. Getting back to the topic of driving, so Germans are very willing to punish people that don't obey the traffic rules, like by honking at them or whatever. Are you nodding? You've been to Germany? Aha, so my claim is corroborated here. And I always have to tell myself not to do that here. But for example, here, there is a rule about how to turn left at an intersection, but almost nobody knows it. Right? It's because when you have a green light, you pull up into the intersection. And then when there's space, you go left, right? But most people stop at the line, even though they have a green light, when they want to turn left. And it's just one of many, many examples where very clearly what people actually do is in conflict with the rule that they actually learned, right? So all the explicit rules for driving, there are explicit rules that exist, but they aren't actually what people do necessarily. And this is what everybody tells you if you're starting a new job. What you're supposed to do is learn the unwritten rules. And what they mean by that is that the rules are not the rules, right? What we think the explicit rules are very often are nothing like what the actual rules are. And the actual rules are only learned from building up that example library of how to behave in these different situations.
It's actually, I have something to add on that. It's funny that you bring up the unprotected left turn as an example for that, because I actually failed my first 2 driver's tests because of the unprotected left turn, because I lived in a part of the city where they didn't have those, and so I didn't get that experience encountering them. And so in 2 different ways, I messed up understanding how they worked.
Yeah.
In an older part of the city where they did use them.
Yeah, so see, that's a great example. So the point is, right, the example-based learning only works if you actually encounter the right examples beforehand.
Jacob, you want to hand that back to Sarah? It's funny to think about driving. I drove in the Bahamas one time where it was like the steering wheel's on the opposite side. And in the area, I mean, literally, I was completely vapor locked when I got to an intersection. I didn't know how to, and I was also on the other side of the road. I just didn't even know what to do because I had no case. So it was complete rational thinking, and the speed at which I could think was so slow that I would just sit there, like, how do I do this? So,
and be like, which lane?
Yeah,
goes
exactly.
which way?
Sarah.
So I've wanted to ask, I've been to a lot of different lectures about the subject of intelligence just because it's something that is interesting to me. And one of the things I've wanted to ask is, I know that IQ is a common way that as a kid you're told intelligence is measured. And for example, all the standardized tests, the SAT, AIMS, AZ Merit, all of those measure IQ in some way. And so I was wondering where this idea of IQ you think comes from, both biologically and socially, and how that is actually related to what you're studying as intelligence.
Mm-hmm. Yeah, that's a great question. So historically, maybe that's what you mean by socially, where that idea comes from is that in psychology, people have done different things to measure basically skill level in some different types of situations or tests or questions on tests. And it turns out that many of them correlate to each other. So if you're very good at imagining this 3-dimensional object and what it looks like from the other side after just looking at a picture of it, that correlates with things like how many letters, random letters, you can remember in a sequence and stuff like that. And from finding that these correlations existed, psychologists derived this concept that they call general intelligence. And then the IQ tests are meant to be a test that tests this level of general intelligence. So this is where it comes from, right? And this is what people care about it. And then people, meaning psychologists, and people who hire people, and all kinds of people use that because they somehow believe it'll be predictive of a lot of different abilities. And psychologists actually try to study, well, what makes one person have a higher IQ and another person have a lower IQ. And this is debated, so there's not really there's not a perfect consensus on it, but things like the amount of your working memory appear to play a role. So like that letter sequence, that random letter sequence, or telephone numbers or whatever, how many numbers can you keep in your head right at one time and then write down afterwards? That's what loosely gets termed the working memory. It's sort of how many things can you process in parallel maybe. And it's somewhat consistent from one task to another. So if I tested you on that now and tomorrow and with numbers or letters or whatever, those would be somewhat correlative. Yeah, so that's where the popularity of that comes from. And it is predictive of various things, like, academic outcomes in school anyway. This is not really an academic or evidence-based statement, but well, it's evidence-based insofar as I can say the later in life you are, the less relevant it becomes, right? So there's a lot of work now, for example, in graduate programs, use the GRE, which is sort of like the SAT, just a few years later, right? And there's more and more evidence that is not terribly predictive of how well people do in graduate school. Now, I don't want to say that it doesn't predict anything, because I do think it does. But the fact of the matter is there are a lot of other things that play a role on how successful you are in life. Among other things, maybe how good you are at finding out what a good goal is to have. But yeah, so I don't know if this is where your question is leading, but as far as I'm concerned, you should probably not worry about those tests too much, except insofar as they enable you to actually go to the next schooling level. So you shouldn't ignore it. But it's also known, it's well known that you can practice for those tests. And it doesn't, there's all these programs, these apps and so on, where people can practice essentially exactly those questions, like the three-dimensional turning thing and whatever, that are asked on IQ tests. And you do get better at those if you practice it. So for one thing, that tells you it's not totally genetic. But you only get better at that. It's not that you become more intelligent in every area in life. You just get better at that particular test, right? And so that tells you a strategy for how to pass the SAT well. But it also tells you that it probably isn't all that relevant for knowing what's going to happen to you later in life or in every area of life.
Let's go. We're going to do three more questions. We'll do so Abel, go back. Okay, go ahead.
So would you say, would it be correct to say that like the role of introspection and metacognition is to allow us to predict the next example without actually experiencing it? Because like the reason why I say that is because like especially in chemistry, right? A lot of the laws and like all the laws about how everything reactions play out, we get that from examples, but only to a certain extent where where we might not be able to like have the time frame, and it kind of goes back to someone else's point about where we don't actually have the time frame to run the example, so we have to make a prediction on how that example would work out. So would you say that introspection is something that allows us humans to predict the behavior of something that will happen?
So I will say that I think introspection is never a good strategy for anything. I don't think it'll allow you to I don't think introspection per se will tell you how the reaction is going to play out. But what I am, of course, also saying is that we can have scientific progress and we don't have to learn everything from our own example learning, right? We don't have to learn about how every chemical component will react with another chemical component from our own example library of putting them all together, right? We can learn something from a book. We can learn what the principle is of what the rule is about how different molecules interact with each other. So we do have that rationality. We do have that ability to learn, the rule of how a pattern will work and then make predictions based on that. What I'm trying to say, though, is that everybody's intuition is that that is how all our decisions work. And evidence is that most of our decisions do not work like that at all. But maybe chemistry does work like that, right? So when you're deciding what chemicals to put together, maybe you should employ that faculty.
I think both apply. I think recognition of patterns is huge in a field like chemistry. Just look at the periodic table. Chemistry is a pattern-based discipline in many senses, but it's also very case-based in the sense that there are cases where you observe an outcome and you can identify what that would happen, and then you can look at a series of cases. That's what synthetic chemistry is. You look at a series of cases, and then after a while you go, yeah, when I do this, I bet you this is going to happen because I just saw it happen 100 times when I did this. So,
Yeah. very much.
So it's a combination of the two. Sophia.
So at this point, my understanding of what intellect itself is getting a little bit mushy and confused. But this is a question I had before I started thinking very deeply about all of this. So it'll sound a little bit off after all of this conversation. But I often hear people talking about how you can get smarter as you age. And it's always struck
incredibly
me.
Implausible to you.
Yeah. It's always struck me that actually we're just gaining more knowledge. It's like we're gaining more examples to go into that database, but we're not actually improving our ability to learn from them. Is that true? Is that not true? How is our ability to learn from the database?
So what I'm saying is that is what intelligence is, having those more examples. There is nothing else. And the nothing is not true. But mostly, mostly our intelligence, our intellect is actually that thing that is kind of mushy, that is kind of like machine learning. It's just building up that large example library. And this is why older people make better decisions. Because they have that much larger space of examples. And they have, therefore, that red line that distinguishes them, right, is much more curvy and precise because they have so many examples to fill that space out with. So that's usually why people drive better after they've driven for longer, right? That's why they have better ability to predict what is going to happen in a chemical reaction if you've seen more different ones. And so what I'm arguing is a lot of the things we think, right? We want to think that intelligence is more than that. That intelligence is somehow extracting the general laws from all those examples and then being able to use the general laws. But what I'm saying is, yes, we can do that, but only in these incredibly rare cases. And I think we have to force ourselves to do it with these scientific methods. But in most cases in everyday life, that is not how we operate at all. What we operate like is not extracting anything from the examples, but just the examples. And having that line between the examples and then matching each new situation to an example that it's close to and deciding based on that. And what I'm arguing also is that that looks like what we think of intelligence. A lot of the things that we think of as being intelligent decisions can be explained by assuming that they're done by comparing the current situation to an example and then just deciding based on the similarity to an example. So it looks like intelligence, but in some way it's not what we imagine intelligence would be.
So it sounds to me like you're also arguing that intelligence is more about the volume of your database and less about the rate at which you acquire data to be in it. Is that what you're saying?
So the younger you are, the more the rate matters, right? Because that is what she was asking about. What matters is the volume of the database, but how do you get that volume? Obviously, if you're 20 and you have a high rate, then by the time you have you're 30, you're going to have a huge volume database. But if your rate is low, then going from 20 to 30 won't change that much about your volume, and it'll be lower than somebody had a higher rate, right? So the rate, in a sense, it doesn't matter directly. It's just the volume that matters in this view. And the point is, right, why this seems counterintuitive, right? So that you're feeling that this makes intelligence into a mushy thing and not as nice and clean as those laws that physics talks about, right, is right. It's kind of less satisfying. But the fact of the matter is, for example, this is what this speaks to all these different examples that I was bringing. For example, artificial intelligence, right? So artificial intelligence is going nowhere when people try to extract the laws of Go, right, or something like that, or of driving for that matter. But once they accepted that all we needed was hundreds of examples, millions of examples, now, right, all those engineers at Google, what they basically believe is that we will have hugely capable artificial intelligence if we can just go from 1 million to 1 billion images of cats and dogs, or whatever the topic of interest is, right? That we will have perfectly self-driving cars if we can just increase the volume of the database of all the situations that these cars could encounter and then have them make the right decisions. There's many elements to the self-driving cars, as the actually visually recognizing what's happening, but also traffic rules and what is the right decision when you have to choose between things. So there's all different aspects to it. But ultimately, right now, what artificial intelligence is all about is gathering that volume of data. And people, right, computer scientists basically think if we just make the volume big enough, we can solve any problem we want. with artificial intelligence.
Okay, we got one more question. I mean, can you imagine if you went through your day, though, I just want to make a comment here, trying to actually calculate analytically every single decision you made? I mean, you'd be tired. You'd want to go back to bed after 10 minutes if you actually approached your life in full rational mode. I don't know. I just was thinking that. Eric, you're going to end the entire series. Go ahead.
I was thinking of my wife works with students with autism, and I was thinking of them with your question. But so I'm not to be speciesist or egotistical or anything, but right, we always want to say these animals, they're not intelligent. But if we're going to go with your example-based system, isn't it fair to say that humans are the most intelligent because we have the richest set of communications, experiences, examples that we deal with, just based on peoples and technologies and our histories and our books and stuff from, pre-man to hayseeds to Renaissance people or whatever. I mean, isn't that just a step in the examples?
Yeah, maybe. I mean, so I'm not, I always play the role of the person saying, well, humans are not that different from all these other animals. But I do recognize that we are, by some measures, right, more intelligent than all those bees and monkeys and whatnot. So I agree with you. But why is that, or what is it that really is different? So very clearly, language is very different, right? So even though qualitatively, there's all these different animals that have symbolic communication, but none have it to quite the degree that we do. And then the other point you brought up is that it's not just that we have language, but writing. And I would even argue specifically it's writing, but it can also be oral tradition. But we have this ability to have this very abstract communication, not just in terms of me producing a signal that means that is monkey, and there's no monkey in the room, and yet you all know what I'm talking about. But even just more complex, that I can talk about something that happened a generation ago or 10 generations ago, right? And this incredible abstractification, if that's a word, right? And passing on of knowledge that is so remote from our current experience. So that's got to have something to do with it. Whether I would say that builds up our example library, I'm not sure. Maybe. So it is true that, for example, athletes, right, they do train motions by even just imagining those motions. And it's also true that brain circuits in our brain get activated just from watching somebody else do something, right? Almost the same brain circuit gets activated from me watching you do something as if I was doing it myself. So presumably our experience gets enriched even just by seeing other people do things or reading about them doing things and us then imagining it. So yes, I think you're probably right. I think, though, there's a lot to be said for personal experience for those everyday life decisions that are example-based. And I do think that there is, I've been arguing all evening against it, but I do think that there is that tiny sliver of actual rationality, of actual ability to extract laws from examples. And I do think that thing is actually unique to humans. And the problem is we haven't really directly studied it very much because we've been so clinging to that being the overarching principle. And we basically know it is not, right? We know that most everyday decisions are not made based on that. But we do have it somewhere. And so I would think that is also one thing that is really unique to humans, and I wish it was more explicitly studied when it started and why it started.
Well, Professor Anna Dornhaus, thank you so much. The QA Science Lecture Series is brought to you by the College of Science, or the QA Podcast, and the UA Honors College. I want to thank the teachers for a wonderful series and the honors students for a wonderful series. This has been awesome. Let's thank Anna for her time. And we'll be back in some form. I don't know what that form will be, but we're going to be back with the podcast. Thanks, everybody.
Thank you.
Hey.